Alright, we're going to do our best here for an instructional video about a mechanical governor governing the speed of an engine. I haven't made this a permanent setup, but it is set up so that this flyball governor will control the speed of the engine by turning the carburetor lever. Now this is the throttle for the carburetor right here, and you can see that as these balls go faster and faster and centrifugal force makes them fly out, the effect that that has on the throttle lever. Now when it's sitting at rest, the throttle is basically wide open. As soon as the engine starts and the governor comes into play, it will throttle the engine back to what we're going to call the desired running speed. And in a perfect world, it will hold it at that running speed. If a load is imposed on the engine and this starts to slow down, then it will open the throttle to keep the engine speeded up as close to the set RPM as it can. Now some things don't scale particularly well. Normally a governor this size would be used with a much larger engine. But once I start it and it runs for a second, I'm going to just put my finger on here and put some drag load on this flywheel, and when it senses the drag load on here, you will see this actually give it more gas, because I'll have slowed the engine down by putting my finger on there for a drag load, and as soon as it senses the engine slowing down, it will open the throttle and do its best to keep the engine running at the preset speed. Once I take my finger away and the load is gone, then the engine will rev up, and this will again adjust the throttle to slow the engine down back into the preset speed that we have asked it to govern things at. So I'm going to go around and start this, and you may not be able to hear me saying too much, but you will see this. You'll see the governor balls fly out. You will see the influence it has here. And then when I put the load on, you're going to see the governor trying to compensate that and keep the RPM at a predetermined value. It'll have to warm up there for a minute. But you can see what's happening over here. Once the engine started and the fly rates flew out, that cut the speed back. This is the governed speed right now that we're aiming for. Now I'm going to put a load on the flywheel, and when I do, it'll try to slow the engine down. And you can watch over here, and you can see this compensate by opening the throttle. See how it opens the throttle to maintain the engine speed even though there's a load on it? And as soon as I take the load off, the engine starts to rev up, so it closes the throttle to maintain that speed. And that's why they were called a governor, because they governed the speed that the engine ran at. So that's quite visible there. I can change the speed by dialing this knob right here, changing the tension on these strings. But I'm going to say, for all intents and purposes, this is the governed speed we wanted to achieve. That's the effect of a load put on it. That's the effect of the load taken off. So you can see the governor from here responds quite well to that. Now if this was a larger engine, of course, it was a 4-cylinder or an 8-cylinder, differential here. But this demonstrates perfectly how a governor controls things. And now that the engine is closed, it's opened the throttle wide open because that's the default setting. I hope this made some sense. I hope it leads to a somewhat better understanding of the way these mechanical governors operate. Thanks for having a look.